Before we move on with formula writing, please take time to copy down the information on this slide into your notes. All right, so we're going to be looking at ionic compounds. Ionic compounds are compounds that contain metals and nonmetals. Ionic compounds form when positive ions react with negative ions, when your metals react with non-metals. All right, there are two types of ions. Ions are either positive or negative. A positively charged ion is called a cation. A negatively charged ion is called an anion. Ions are atoms that have a charge. And remembering there are two types, cations and anions. You'll be able to predict the charges of these ions based on where they are. Main group elements you can predict the charges of main group elements only from main group elements. So on your periodic table, we want you to write this information. Above group 1, you will write positive 1. Above group 2, positive 2. Going over to group 3, positive 3. And when you get to group 4, it's going to be either negative or positive 4. If it's above the zigzag line, it's going to be negative. Below the zigzag line will be positive 4. Group 5 will be negative 3. Group 6, negative 2. Group 7, negative 1. Group 8 will be neither positive or negative. So please make sure you number the main groups 1 through 8 and that you identify the oxidation number for the main group elements. Please note that I did not write any charges above the transition metals. You cannot predict the charges of transition metals. So please do not write any charges above the transition metals, only the main group elements. All right, so when we're writing formulas, since we're talking about ionic compounds that have charges, we want to make sure that we balance out the charges so that the charges equal 0. The naming system that we use when we start to name these compounds is the International Union of Pure and Applied Chemists. You do not need to know or memorize this. You just need to know that the naming system is based on the International Union of Pure and Applied Chemists. This is the naming system that we will use. So they're starting with binary compounds. Binary compounds, a prefix bi means 2. So our binary compounds will only contain 2 different elements. Again, please make sure that you note that it's 2 different elements. Writing different at the top. Okay? Binary compounds, 2 different elements. All right, when we have our binary compounds, ionic compounds, the metal will always be written first. For our binary ionic compounds, 1 metal, 1 non-metal, and the metal will always be written first. When we have ionic compounds, we have a transfer of electrons. Those ionic compounds are not molecules. All right, when writing binary ionic compounds, again, the metal is written first. You're going to crisscross their charges. Crisscrossing the charges will balance them so that your compound is neutral. It has an overall charge of 0. And when you crisscross those charges, you'll drop your positive and negative, and you'll only be left with subscripts. So let's look at magnesium chloride. The symbol for magnesium is Mg. And if you look in group 2, magnesium has a charge of positive 2. And then chloride, the IDE lets us know we have a negative ion. And when you look at group 7, you'll see that chlorine is in group 7 and it has a charge of negative 1. So you have 2 positive charges and 1 negative charge. How do we get this to balance out? Well, there are two ways we can make this happen. We can crisscross the charges so that when you write the formula, you have MgCl2. But let's look at this a little closer and see how that happens. Why does that work? Well, you have magnesium that has a positive 2 charge, chlorine that has a negative 1 charge. When you add a +2 and a negative 1, that equals positive 1. We need our compound to balance out so that it has an overall charge of 0. So if you add a second chlorine ion, you now have 2 negative charges that will balance out with the one positive 2 charge of magnesium, All right. So let's look at another example. We can crisscross the charges, or we can simply crisscross the subscripts, superscripts to subscripts, or we can simply balance them out. So let's take a look. Barium has a charge of +2. Look in group 2, you'll see barium has a charge of +2. When you look in group 6, you'll see that oxygen has a charge of -2. All right? So you can crisscross the charges to get BaO. Whoa, but what happened to the +2 and the -2? Well, you always want to make sure that you write ionic compounds in the simplest form. And a +2 and a -2 will reduce to 1. And when we write ionic compounds, we do not write ones. Just like in algebra, ones are understood. All right? So again, this 2 right here, these 2 cancel each other out. They both reduce to 1. All right, so let's practice. Let's see what we have here. And you have, if you look at your periodic table, take a look. Sodium, let me get my marker here. Sodium, if you look at your periodic table, has a charge of +1. Looking at your periodic table, bromide has a charge of -1. Well, remembering ones are understood. So when I crisscross those charges, I get +1, -1, and I drop the charge to give me NaBr. But notice, if you have a +1 plus a -1, what does that equal? It equals 0. All right, let's look at our next example. You have calcium fluoride. Calcium fluoride. Okay, so that should simply be an F. All right, here we go. Calcium has a charge of +2. And if you take a look in group 7, fluoride has a charge of -1. When you crisscross your charges, your +2 comes down here, your -1 comes down here. Well, then you're left with the formula CaF2. Now remember, I don't write this 1 because ones are understood. Let's look at this another way. Calcium has a charge of +2. Fluoride has a charge of -1. Well, if I have +2 plus a -1, that equals, oops, let me fix this real quick. All right, there we go. A +2 plus a -1 equals a +1. Well, that's not going to work. So how do I get this to be a neutral compound so that it equals 0? Well, if I add one more fluoride ion, that gives me an overall charge of 0, because now we have a +2 and we have 2 negative charges right here. Now this is a shortcut right here when you crisscross your charges. This is a shortcut. This shortcut just simply shows us how the charges balance out. Let's look at another example. Let's say we look at magnesium and oxygen. Well, magnesium has a charge of +2. Oxygen has a charge of -2. When you crisscross those charges, you will get Mg2O2. But we have to write our compounds, our ionic compounds, in the simplest forms. Ionic compounds are always written in the simplest form. So when we take a look at this, we've got to reduce these numbers. And so that becomes MgO. So here we have a 2 plus and a 2 negative. A positive 2 plus a negative 2 equals 0. All right. Next example. Let's skip down. Let's look at aluminum oxide. Looking at your periodic table, aluminum oxide has a positive 3, oxide negative 2. Let's crisscross these charges. So that becomes a 2 negative here and a 3 positive here. So when you write your formula, remember we're going to drop these charges. So that becomes Al2O3. And how can we make sure that this equals 0? Well, remember you balance out your oxygens and your aluminums so that you have 6 positive, 6 negative, which will equal 0. Looking at potassium oxide. Potassium has a charge of positive 1, oxide negative 2. Crisscross those charges, K2O. All right, so now we're going to move on to our next example. So now we have transition metals. Transition metals are rebels. They don't follow the rules. Transition metals have multiple oxidation numbers, okay? So they have more than one charge. So iron, take note, in order to determine whether we have iron 2 or iron 3, you will use Roman numerals. Transition metals are different from main group metals. Transition metals have multiple oxidation numbers, where main group metals or main group elements only have one oxidation number. There are exceptions to that rule. Zinc and silver. Zinc will only have a charge of +2, and silver will have a charge of +1 only. Okay, so let's take a look at this. Some metals have more than one oxidation number, and we're referring to transition metals. Whenever you have transition metals, there will be a Roman numeral written to identify the charge, with the exception of zinc and silver. Remember, zinc is always +2, silver is always +1. So let's look at this. Copper 1 chloride. What does this 1 tell us about the charge of copper? This 1 tells us that copper has a +1 charge. And if you look in group 7 of the periodic table, you'll see that chloride has a charge of -1. When you crisscross those charges, and because ones are understood, you simply have CuCl. But now looking at copper 2 chloride, what does this Roman numeral tell us? Copper 2 chloride. That Roman numeral 2 lets us know that copper 2 has a charge of +2. And just as before, chloride has a -1 charge. When you crisscross those charges, you get CuCl2. All right, so let's practice. Here are those two examples done for you, but let's look at copper 1 oxide. So copper has a charge of +1. We know that because it's plus. And then we have oxide that has a -2 charge. When you crisscross your charges, just as we did before with the binary compounds, you have Cu2O, because we crisscross the charges. When we look at 10,4 bromide, well, look at 10. What is 10's charge? That Roman numeral tells you that 10 has a +4 charge. And again, we know it's positive because metals are always positive. So we're going to write 10 with a charge of +4, and bromide with a charge of -1. When you crisscross those charges, you get 10 SnBr4. Okay. All right. So now we're looking at forming ternary ionic compounds. I'm going to stop here, let you practice, take a look at the video, and then I'm going to come back. And when I come back, I'm only going to discuss on how to write these. So make sure you pay close attention to the video coming up.